we're back in 7.5. We're going to do example 3. I didn't title example 3, but this is actually the difference of two squares, and I want to show you how to factor that. It's actually really super stinking easy. I think you're going to love it. But you got to make sure you actually have the difference of two squares. The first thing I want to do is for A, B, C, D, E, and F. First thing, I'll make sure that every one of them is actually a difference, okay? So you see the subtraction sign. You should see a subtraction sign. If you don't, if you see an addition sign, it is not the difference of two squares, okay? So first of all, you have to have a subtraction sign because that's what the difference means. Now two squares, remember what I told you a square is. If it's a number off our top 25 list of perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, etc. Okay? Those are all perfect squares. It's a number that I squared to get that number in question. Okay? And if it's a variable, then the variable has an even exponent. If it has an odd exponent, it is not perfect. So can you kind of scan your page and find where you see an odd exponent? Do we see any odd exponents anywhere on our variables? Okay, guess what? Did you see that 5 exponent on the y? Right away, I can tell you this is not a difference of two squares. So guess what? It's not factorable. Okay, so remember what we learned in example 1. Let's make sure it's a perfect square trinomial. Let's check it and we'll test it. This is a great way to tell before we even get started. This is not a difference of two squares, okay? It's not factorable. So we're going to leave this one alone. F is not factorable because it's not a difference of two squares. We don't have an even exponent on our variable. Nothing I can do about it, okay? Now let me show you how to do the difference of two squares. I think you're going to love it. It's not the sum of two squares. It's definitely the difference of two squares. I can't tell you how many times people have tried to factor a sum of two squares, and they really think they did it right, and you can't. The sum of two squares is not factorable. They never are. The difference of two squares, factorable all the time. All right. Now, if you recall, we're missing the middle term because outer and inner canceled. Do you remember that from chapter 6? When we foiled it, we're like, oh, look, outer and inner cancel each other out, and we're just left with first and last. Remember, that was our FLA adventure. We didn't foil, we just did FLA, F-L, first and last. And so you're going to end up with two binomials, and they're going to be exactly the same numbers and variables, except one's going to have a plus sign in the middle and one's going to have a minus sign. They're going to be identical except for those signs in the middle, okay? So let's start with x squared. I'm going to break that up. I'm going to put one of the x's here and the other one here. And then 81, I'm going to put 9 here and 9 here, okay? And so if it's a difference of two squares, you should have two quantities, two sets of parentheses written. They're identical except for the sign in the middle. So it should be x plus 9, x minus 9. As always, please, 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 please check it. Foil this guy out. Make sure it is right. Don't just assume, because you can always check it and make sure. So first would be x squared. Outer is negative 9x, inner is positive 9x, last is negative 81. Yep, those cancel, and I'm left with x squared minus 81. It checks out. Okay? So, and we factored it correctly. All right, let's look at B. We need two quantities. Okay, put two quantities up there. 9p to the 4th. Now I'm going to split that up. That's going to be 3p squared, 3p squared. Now where did I get that? Well, to break up 9, it's got to be the same number times itself to give me 9. Well, that's 3. 3 times 3 is 9. Now for the exponents, if you want to split them up, just cut them in half. P to the fourth split in half is p squared. So we'll put p squared in one quantity and the other p squared in the other. Okay, so if you're wondering, that's how. 16q squared, that'll be 4q and 4q. Why? Because 4 times 4 is 16. Q times q is q squared. Make one of them positive, the other one negative, and voila, you are done. That is how you factor that. Okay? Let's come down to C. You need 2 sets of quantities. They're going to be identical in every way except for the signs in the middle. So let's start with x to the 6. Now I want to break that in half. Half of 6 is 3, so I'm going to put 3 of the x's here, 3 of the x's there. And then let's look at this. Ooh, what's wrong with that 7 there? You're right. It's not a perfect square. So you know what? This is one I would say is not factorable. Sometimes you'll start them and you'll kind of get your engine going, and then you'll go, wait a second, that number's not even a perfect square to begin with. So we can't do that. All because of that stupid stinking 7. Okay, it is not a perfect square, so it's not factorable. Okay, let's go to D. You need 2 quantities. We think it's a difference of 2 squares, so we need 2 quantities. Let's break up the 1. 1 times 1 is 1. Let's break up the 4x squared. That's 2x and 2x. I need a plus and a minus in the middle in each one respectively. And then just check it. See what you can do with it. And let's do first. 1 times 1 is 1. Outer is negative 2x. Inner is positive 2x. Last is negative 4x squared. And these cancel out, leaving me with 1 minus 4x squared. So yeah, it checks out. I know for a fact this is my answer. Really good. Very, very good. I do encourage you to check it. Just be sure. I'm going to leave letter E for you. No trickery there. It is a perfect square. P to the 8 is perfect. 49 is perfect. Q to the 6 is perfect. And it's a difference of 2 squares. It is factorable. So give it your best shot and check it. All right, please bring your questions to class, and I hope I made perfect and total sense.